Hello everyone. Myself V. Krishnaveni, working as assistant professor in the Department of Physics from Marri Laxman Reddy Institute of Technology and Management. So today I am going to explain about the quantum physics and solids in this. The topic is application of the Schrodinger wave equation, that is particle in one-dimensional box. So let us go for the slide. Next slide. So here the application of Schrodinger wave equation. So in the last class, we have derived the Schrodinger time independent wave equation. So that is each and every moving material particle has some wave equation. So that is derived by the Schrodinger in the year 1926. It was in the last class. So now what is the application of the Schrodinger wave equation? So here we are considering one particle, that is material particle. So the material particle here, it is electron. So electron having, but here the electron is kept inside the potential box. What is the energy of this electron? Let us go for the derivation. So derivation here, it is entirely the mathematical derivation, application of Schrodinger wave equation. So for this, the particle in one-dimensional box. Suppose the particle is electron kept inside the one-dimensional box. So one-dimensional box means here the electron which is moving only along x direction. So let us consider the electron which is moving along the x direction, which is enclosed in the potential box, which is shown in the figure. So here x equal to 0 and x equal to L. So here the particle, here it is a particle which is electron, which is moving here and there inside the potential box. So here one dimension we are saying. Why? Because here the particle is moving only along x direction. So here infinity potential box it is. So infinity potential box means the potential energy at the walls of the box is infinity, and inside the potential energy is 0. So at the walls means the boundaries of the wall, that is x equal to 0, another one is x equal to L. So inside there is a particle will exist. The width of the box is L. So inside the box only the particle is roaming here and there. So that is the particle is here L, having the mass m, which is moving along only x direction. So for this electron we are going to deriving the energy E as well as the wave function psi. So we are going to determine the value of E, that is energy, and also wave function by using Schrodinger time independent wave equation. So we are using the Schrodinger time independent wave equation. They're going to determine the energy as well as the wave function. So next one. So here the particle, that is electron, between the walls, which is no forcing acting on the particle. So the particle is free to move inside the box only. Means the particle has only the kinetic energy but no potential energy. The particle is free to move inside the box, that is the particle is having the kinetic energy but not potential energy inside. But whereas outside the box the potential energy is infinity but kinetic energy is 0. Here the kinetic energy is the 0. Particle is inside only moving, the particle is moving, so that's why it has the kinetic energy but no potential energy. Outside potential energy is infinity and kinetic energy is 0. So for this electron we are going to determining energy E. So that is V equal to 0. Inside the box V equal to 0, that is x equal to 0 and x equal to L. So x equal to 0 and x equal to L are the boundaries. So within the boundaries the particle is moving. So the potential energy is 0, kinetic energy is non-zero. So boundary conditions. So what are the boundary conditions? That is potential energy, first boundary between 0 less than or equal to x less than or equal to L, that is between the box, that is 0 less than or equal to x less than or equal to L. So between the box the potential energy is 0, and surface of the box the potential energy is infinity. So that is x greater than or equal to 0 as well as x greater than or equal to L. So x greater than or equal to 0, x greater than or equal to L, simply you can write in the short form 0 less than x greater than L. So at the walls the potential energy is infinity. So these are two are the boundary conditions. So that is V equal to 0, V is equal to infinity. Next, What is a wave equation? That is d square psi by dx square plus 8 pi square m into e minus v by h square into psi is equal to 0. So here v is equal to 0 we have taken. So v is equal to 0 because inside only the particle is roaming here and there. So that's why v is equal to 0. By substituting this, we get the d square psi by dx square plus 8 pi square m into e by h square into psi is equal to 0. So after substituting v is equal to 0, we will get this equation, that is equation number 2. Next one, for each and every equation there is some solution. Suppose x square plus 5x plus 6 is equal to 0. So x has two solutions. So that is, by substituting x you will get the solution. So that is x value 2 comma 3. So here minus 5x. Suppose x equal to 2 or x equal to 3, substitute it, then this is the solution of this equation. Similarly here also there is a equation, that is second order differential equation, which has solution. The solution is psi. So the wave function is psi. So wave function psi is equal to, what is the solution assumed by the Schrodinger as a sin kx plus b cos kx. So where x is the position of the particle, a and b are the constants, and k is the propagation or wave vector. So by substituting the boundary conditions, then you will get the a comma b values. So what is the first boundary? X equal to 0. So when x equal to 0, what is the wave function? Psi. That is, at x equal to 0, the particle is not at all moving. So the wave function is 0. So when x equal to 0, what is the equation 3 will becomes? LHS will be 0. RHS is a sin k into x. In place of x, write down the 0. So k 0 plus b cos 0. So cos 0 is 1. Cos 0 is 1. But sin 0 is 0. So obviously you will get b value 0. So next boundary condition is x equal to L. So at x equal to L, again psi value 0. At x equal to 0, again the psi value why it is 0? Because the particle is not moving. So again psi value 0, but LHSI again 0. A sin, in place of x, write down L. So sin KL plus b cos KL. So LHS is 0. A sin KL plus b cos KL. In place of b, write down 0. So the second term will becomes to 0. So A sin KL is equal to 0. So here in this condition, A sin KL is equal to 0 means either A equal to 0 or sin KL equal to 0, but not both to 0. So one should be A sin KL should be 0, but A should not be equal to 0 because A is a constant. So that's why A should not be equal to 0. But only probability is only sin KL is equal to 0. So when sin KL value will becomes to 0, because when theta is equal to, that is KL is equal to 0, sin KL 0. For theta, KL is equal to pi, sin pi 0. Again sin 2 pi, sin 3 pi, sin n pi. That is sin n pi will becomes to 0. Means the KL value should be n pi. So KL is equal to n pi means K is equal to n pi by L. Substitute n pi by L in this equation. Equation number 3. What is equation number 3 again? Psi is equal to A sin kx. K in place of K, n pi by L. X is already there. Plus cos b, in place of b it is 0. So now the equation becomes to what? Psi is equal to A sin n pi by L into x. So where n is a integer. Where n is integer. So now differentiate this equation number 4 by 2 times with respect to 2x. What we will get? That is d psi by dx. A sin will becomes to A cos. N pi by L into x is as it is. Again do with the theta. So in place of theta we have n pi by L into x. So x is 1. So n pi by L. Again differentiate with respect to 2 x with respect to x again one more time. Then you will get d square psi by dx square. Cos theta differentiation is sin theta. So minus A sin n pi by L into x sin n into again n pi by L n pi by L whole square. And now A sin n pi by L into x will becomes to psi. Substitute the psi value from equation number 4. Since from 4, so from equation number 4, you will get d square psi by dx square plus n pi by L whole square into psi is equal to 0. Now let us compare the equations, that is 2 and 5. So what is 2? What is 2 here? That is d square psi by dx square plus 8 pi square m into e by h square into psi is equal to 0. So by comparing equation 2 and equation number 5, then what is the difference? That is 8 pi square m into e by h square is equal to n pi by L whole square. So by comparing the energy value, you will get what? Here pi square gets cancelled. So finally you will get n square h square by 8 ml square. So here E is equal to n square h square by 8 ml square. What is this expression? That is energy of the particle. What is the particle here? Assume that is electron. So where n is what? 1, 2, 3. That is substitute n, E is equal to 1, n is equal to 1 h square by 8 ml square. N is equal to 2, then 4 h square by 8 ml square. N is equal to 3, 9 h square by 8 ml square, and so on. Then what is general equation? That is En is equal to n square into E1. Therefore, the particle in the potential box, the energy is discreted but not continuous, means it has only certain values but not all the values. So this is energy levels as shown in the figure. So here what is the conclusion from the quantum mechanics? What you can say, that the energy is absorbed or gained in the form of discrete but not in the form of continuous. So which will exhibit only the discrete energy, not continuous. That is the conclusion of the quantum mechanics. So continuous means which can exhibit any amount of energy, but discrete is only certain amount of energy. So like stepwise is only certain energy, that is discrete energy. But when you take the slide, so it is a continuous energy. But here it is a stepwise. N is equal to 1 energy, n is equal to 2, n is equal to 3, and so on. So that is from the application of Schrodinger wave equation, the energy is in the form of discrete but not continuous. So next, here you got the energy. Now go for the wave function. So how can you calculate the wave function? So by taking the normalization condition. So what is a normalization condition? That is integral, the limits of the box is 0 to L, that is x equal to 0 to x equal to L. So next, wave function is represented by psi. Complex conjugate of wave function is represented by psi star. So psi star here dx is equal to 1. So psi star dx is equal to 1 because psi is equal to psi star. So psi is equal to psi star. That's why the equation will becomes to psi square dx. So integral 0 to L psi square dx is equal to 1. So what is psi? That is a sin n pi by L. So a sin n pi by L into x. This is the value of psi, wave function psi. Psi square is again, so a square sin square n pi by L into dx. So here sin square theta is directly you cannot able to differentiate. By expand the value in terms of cos. So how can you expand? That is cos 2 theta is written as cos 2 theta is equal to 1 minus 2 sin square theta. So sin square here minus 1 minus cos 2 theta written as sin square theta, 2 sin square theta, and sin square theta is 1 minus cos 2 theta by 2. So sin square theta can be written as 1 minus cos 2 theta by 2, 1 minus cos 2 theta. 2 means 2 again already there, n pi by L into x into dx whole divided by 2. So now by integrating this equation, you will get a square is equal to 2 by a by L, and a is equal to under root 2 by L. So how you will get this? Then we will see here. So here 1 a square integral a square by 2, take it as whole common, and 1 dx is x, limits are from 0 to L, minus sin 2 theta sin 2 n pi by L into x, the limits are from 0 to L whole divided by 2n pi by L. So sin, in place of x substitute L gets cancelled, sin 2n pi will becomes to 0. Again lower limit, in place of x substitute 0, again sign 0 is also 0. So this value whole will becomes to 0. Then you will get only the value 0 to L. So in place of upper limit you substitute L, lower limit substitute 0, then what you will get, a square by 2 into L minus 0 is equal to 1. So finally a square is equal to 2 by L. So here you will get a square is equal to 2 by L. So a is equal to under root 2 by L. So you got the value arbitrary constant a root 2 by L already. The wave function is 4, that is psi is equal to root 2 by L sin n pi by L into x. So from this we can conclude that the wave function we have derived and also energy already derived it is. So we got the wave function as well as energy in one dimension. If you consider this one dimension into three dimension, then what you will get, that is wave function is a function of x comma y comma z, because the particle is moving along x comma y comma z direction. So root 2 by L is in one direction, so root 2 by L in y direction, root 2 by L in a z direction. So finally multiply these three, then you will get the 2 into 2 into 2, 8. L is in 3 times, so L cube. So sin n pi by L into x direction, sin n pi by L into y direction, sin n pi by L into z into z direction. The width of the box in along x direction is Lx, along y is Ly, along z is Lz. So this is a wave function in 3 dimension. And in 3 dimension the energy is, in place of n square, write down nx square plus ny square plus nz square into h square by 8 ml square. So now equation 7 and 8. So say equation 7 and 8 are known as wave functions, that is wave functions are and energy of the particle in a 3 dimension, that is 7 and 8 are the energy, 7 and 8 are the here the wave function, that is energy as well as the wave function. So wave function is equation 8, energy is equation number 7. So here the graphical representation of the particle in one dimensional box. So here again the width of the box equal to x equal to 0, x is equal to L. So here the wave function is psi, that is if you take in between the particle is moving, if the quantum number n is equal to 1, it has only one antinode and 3 nodes. If n is equal to 2, then we have 2 antinodes and 3 nodes. Similarly, n is equal to 3, we have 3 antinodes and 4 nodes, and so on. So this is the wave function psi. If you take the square of the wave function, that is psi square, then what you will get, only the positive values. Here the positive and negative values, because the wave function having the positive and negative. When square it, the negative will becomes to positive. So here also there are 3 antinodes when n is equal to 3. Here also there is 2 antinodes when n is equal to 2. Here one antinode when n is equal to 1. Means the antinodes represents the quantum number. So how many antinodes are there? That much quantum number will be there. If it is 1, n is equal to 1. If it is 2, then n is equal to 2, and so on. So here the probability, here psi square is the probability density function. So probability density function is 1, then you can say that the particle is present. If the probability density function is 0, the particle is absent. Here the probability density function is 0 at the walls of the box, probability density function is 1 inside the box.